All right, congruence and transformations. Let's identify any congruent figures in this coordinate plane. Let's start off with the squares. As you can tell, the squares are 4 square units, okay? QPNR and ABCD. They are both 4 square units. So you know they're congruent. How does one become the other? Well, if we look at this, this one is 2 spaces right, and whoopsie, 1, 2, 3, 4, 5, 6 up. Or if we were going from this one to the other one, it would be 2 spaces left and 6 down. Okay, so A, B, C, D, and N, P, Q, R, got to go in the same order to match them up. Because when we move them, they'll line up. Okay, are congruent and translated either x plus 2, y plus 6. So if we're going right and up, or if we're going from ABCD to NPQR, it would be x minus 2, y minus 6. All right. Now let's look at the right triangles closest. Well, I'll just mark them right here. Okay. So GEF. If you notice, G is 1 above and M is 1 below. E is 1 above the axis and K is 1 below. And F is 1, 2, 3 above the axis. And L is 1, 2, 3 below the axis. So GEF and got to line them up. So G matches up with M, K, L are congruent and reflected over the x-axis. And last but not least, we have the 2 in the corners. All right. So for example, let's look at a point. Point I is -1, -2, -3, -4, -5, 1, 2, 3, 4, 5. So I is -5, 5. And T is 5, -5. If you look at your yellow card, basically the numbers switched places. Okay, so -5 became X and 5 became Y. Well, which one does a switch like that? That's a 180-degree rotation. So I, HJ, and UTS are congruent and rotated 180 degrees. If you need to hit pause, do. All right, this one is asking, how can we make ABCD map on to EFGH? Well, first off, let's notice A got EFGH. So A matches up, is supposed to match up with E. B is supposed to match up with F. So pay close attention to that. Now, don't write anything down yet because I'm going to show you there is trial and error with these things. You know, unless you're really visual and can see it, there is sometimes trial and error because there's different ways you can do things. You can flip, you can rotate, you can slide. What's going to work? Okay? So for example, first off, don't write this down. If I just slid this one over 1, 2, 3, 4, 5 spots, all right? My A would be lined up here. B would be here, and C would be here, D would be here, technically prime. Now, if I folded that over, yes, A would match up with G, B with H, B with F, and C with E. That would match up. So that would fold over onto that. But look at the letters. I'm supposed to have, this got erased, A match up with E, B with F, C with G, and D with H. Do I have that? No, I do not. So that does not work. I mean, it does work to get the shape overlaying the other shape, yes. But to get it to match up in the correct order does not work. So let's try something else. What if I folded this over the y-axis and reflected it? Well, A is 1 away. Here's A prime. B is 1, 2, 3 away. 1, 2, 3. Here's B prime. D is 2 away, and C is 4 away. Let's see how this goes. I need A to match up with E, B, and F. Well, let's see. Look now. 1, 2, 3, 4. That works. So not a lot of trial and error, but some. So what's my answer? First off, I need to reflect A, B, C, D over the y-axis. I put my y there. That's step 1. Then step 2 is a translation. 1, 2, 3, 4. 4 spaces down. Okay, technically that would be x plus 0, y minus 4, or 0, negative 4 with the vector on it. Okay? All right, here's some more math gobbledygook. Basically what this is saying is that since lines K and M are parallel, if you take this line right here, okay, and reflect it over, it ends up looking like this. But then if you reflect it again, it ends up looking like this, which ends up being the same thing as if you would have just translated or slid this over. Okay, so it's like, you know, if you fold it over and fold it over again, it's got the same orientation, just down the road. That's what it's basically saying. All right, so there's a lot going on here. In diagram, a reflection in line K maps GH to G prime H prime. Okay, so in other words, the blue line folds over K and becomes the red line, G prime H prime. Then that one is reflected over line M to the green line, G double prime H double prime. Just like we talked about before, it folds over and folds over again, and basically GH is a translation onto G double prime H double prime. Okay? Let's go a little bit further. It also says HB is 9 and DH is 4. All right, we'll come back to that in a little bit. Name any segments congruent to each segment. All right, well, GH is congruent to G prime H prime and also G double prime H double prime. They're all the same line, just being translated, reflected, and all that good stuff. All right, HB. All right, HB is this piece right here. Okay, well, since H folded over line K, that means this is going to be equivalent to that. So this is also going to be 9. Okay, so that is congruent to H prime B. Okay? So HB is congruent to H double prime, I'm sorry, single prime B. And lastly, GA, where's GA? GA is right here. I'll do a different color. That is going to be the same as this one. I'm sorry, I highlighted G prime A, but you get the gist. This one is going to be the same as this. I made the same mistake up there. But basically, it's going to be congruent to G prime A. So we don't know what the measurement is down here, but let's say this was 3, this would be 3. You don't have to write that down, I was just making it up. But just the idea that they would be the same, because it's folded over the line. Just like this will be equal to this, and this will be equal to this one. I'll put 3 marks there. Okay? Same idea, because it's folded across the line, so if it's a reflection, it's going to have the same distance from that line. Does AC equal BD? Okay, I'm going to clean this up. You already have it down in your notes, but I'm going to clean this up. AC, which is right here, is that equal to BD? Well, right here we have these 2 lines here. Okay? And what we have going on is 2 perpendicular sections right here, which means, based on what we've learned previously, if those are perpendicular, these are basically corresponding angles. Okay? Which makes those parallel to each other. All right? And therefore, they're going to be equal. They're basically part of a rectangle. And what is the length of GG double prime? Okay, well, let's see what we got here. So we established earlier that this was 9, this was 9, this was 4, and this was 4. Okay, so if you add that together, 9 and 9 is 18, plus 4, 22, plus 4, 26. The length of this line is 26. Okay, well, by the reflection in parallel lines theorem, that means this piece is going to be the same length as this piece, so it would also be 26. All right. More math gobbledygook, which I will try to translate into a little simpler English. So what they're saying is, we have these 2 lines, the black lines, K and L, okay, and they intersect at point P, okay? Imagine this was the origin. We talked, reflecting, rotating around the origin. Let's pretend that's the origin. What it's saying is, the blue line AB, okay, is reflected across K. All right? So whatever the distance is from here to here is going to be the same from there to there. And whatever the distance is from here to here is going to be the same there. All right? So it reflects. So the blue line reflects over K and becomes A prime, B prime, the red line. Then the red line folds over M, reflects over M, and gives A double prime, B double prime. But what it's saying is, whatever the angle is here, right there, okay, formed by K and M, the angle of rotation all the way this way is double that amount. So if x was 20, 2x would be 40. So we have 2 intersecting lines, again, M and K, intersecting here at P. All right? Now, what it's saying is this angle right here is 70 degrees. Okay? Now, the blue fish or ship or whatever that is reflects over K. And it gives you the red one. Then this one reflects over M and gives you the green one. Well, we just learned that if we're doing the two reflections, from here to here will be twice this amount. So that will be 140 degrees rotation. All right, example 5. A rotation of 76 degrees maps C to C prime. To map C to C prime, use two reflections. What is the measure of the angle formed by the intersecting lines of the reflection? So this one is actually going backwards. So let's have our intersecting lines like so. And here's my image, or my origin, sorry. All right, the intersecting point. Now what it's saying is, pretend this line wasn't here. Don't erase it, just pretend it wasn't here. All right? And I was reflecting from over here to over here, and that was 76 degrees. But I wanted to do two reflections, which means if this was 76 degrees, then this angle here, formed by the two lines, would be half of that, 38 degrees. Right? So it's just moving backwards from what we just did. Hope that makes sense. And then there's your exit ticket. It's in the book if you need to just get it out of there.